Dear students, now we start the most important part of real analysis is the continuous function. In the first level, we know that a function is said to be continuous at point x is equal to x0 if limit x tends to x0 fx equal to f of x0. That means the limiting value equal to the functional value. This is the working rule. So what is that? Continuous function. Let x, d and y row are two matrix spaces and f is a function from x to y. Let x0 belongs to x. Then we say that the function f is continuous at the point x0 if given epsilon greater than 0, there exists delta greater than 0 such that x minus x0 mod less than delta implies fx minus fx0 mod is less than epsilon. In the distance form, we write it as d of x x0 less than delta implies rho of fx f of x0 less than epsilon. That is, x belongs to, this is the condition of the continuous function. A function is said to be continuous at a given point. When we say that a function is continuous on the whole space, a function is said to be continuous on x if f is continuous at each of the points. The examples, the identity function, f is a function from x to x. The identity function is continuous. Similarly, the constant function f r to r, that is also continuous. You remember only this formula. Before we know that a function is said to be continuous at a given point x0 if for each epsilon greater than 0 there exists delta greater than 0 such that x minus x0 mod less than delta implies fx minus fx0 mod is less than epsilon. This up to plus 2. So we don't know what is the distance functions. Now in the distance function form we write it as d of x x0 means distance from x to x0 less than delta implies distance from fx to fx0 is less than epsilon, which implies x belongs to s delta x0 implies fx belongs to s epsilon f of x0. F of x belongs to f of s delta x0 implies fx belongs to s epsilon f of x0. That means this is a subset of this. Now f is continuous on x0 means f of s delta x0 is a subset of s epsilon f of x0. These are the examples of continuous function. There are several examples of continuous function. A function is said to be continuous on the whole set x if it is continuous at each of its points. Then we say that the function is continuous on x.